So guys, now let us discuss the last topic of this network address translation series, and that is twice NAT. So let us begin with the understanding of real world example where twice NAT would be of use. So the network address translation types that we have discussed so far in this course has two common points. The first point is that it was only the source IP address of the packet, in case if the packet is undergoing translation from inside to outside interface, is used to make network address translation decision as per the config, right? So it was only the source IP address of the packet which helps us to make a NAT decision. That is, for example, I showed you many times that network address translation translates to a if condition, that if source IP of the packet is blah blah blah, then change source IP of the packet from X to Y. So here this condition shows that the decision as to how NAT has to be applied on the packet is based on source IP address value, right? And in case of untranslation, it was quite opposite. It was destination IP address which helped in making the decision that how the destination IP address of the packet should change when the packet travels from outside interface to inside interface, that is untranslation. And the second point is that it was only the source IP address of the packet, that is the packet which is going from inside to outside, so source IP address of the packet, or the packet which is going from outside to inside, that is the destination IP address of the packet undergoes translation, right? So it is either the source IP address or the destination IP address that undergoes translation. We have never witnessed a case where both the source and destination IP address or source and destination port number undergo translation at the same time. So this is where twice NAT fits in. In twice NAT, as the name suggests, it is twice. That is, if the packet is going from inside to outside interface, the source IP address, the destination IP address, source port number, and destination port number, all of these four fields can undergo translation. Alright. So this is the first case we are witnessing where when the packet crosses the boundary of the Cisco ASA firewall, both the source IP address and port number and destination IP address and port number undergo translation. Right? So there are occasions where we need to translate both the source IP address and port number and the destination IP address and the port number of the outbound traffic. This is called twice NAT. So going further, let us discuss the use case where twice NAT will be used. So let's say that XYZ Corporation has purchased the DNS service from the Microsoft. So Microsoft is running some DNS server in its intranet on public IP address, let's say 100.0.0.3 and on port number 53, right? And XYZ Corporation pay the fee to the Microsoft Corporation that its internal users, that is XYZ's internal corporation, will use Microsoft internal DNS server services in order to get resolved DNS queries. So for example, if this user of the XYZ Corporation accesses the website www.csepracticals.com, then this user will use the Microsoft DNS server in order to translate this URL into its IP address. As simple as that. So in order to resolve DNS queries, all internal users of XYZ Corporation has to send the DNS resolution query to IP address 100.0.0.3 and this is UDP port number 53 because DNS runs on a UDP port number. Because DNS runs on a UDP protocol. So here we are using UDP port number 53, right? So all the employees of the DNS Corporation knows in advance that in order to resolve DNS queries, they have to send the traffic to public IP address 100.0.0.3 and UDP port number 53, right? So now XYZ company don't want its internal users to use DNS service from any other public server such as Google, which is located at 100.0.0.2. So let's say it is a Google corporation. It is also providing its DNS service to the public, and let's say that its DNS server is present at public IP address 100.0.0.2 and the UDP port number 53. But XYZ Corporation wants its internal employees to always use the DNS service of the Microsoft Corporation and not that belongs to Google, right? So how to enforce this rule on all the users of XYZ Corporation? That's a problem statement. Even if any internal users of XYZ Corporation cheats and try to use the Google DNS server in order to resolve its DNS query, the XYZ Corporation wants to play a trick that any packet that is being sent out, it's a DNS query packet, which is destined to IP address 100.0.0.2. XYZ Corporation wants to install a rule on its ASA firewall that this DNS query, which is destined to Google's IP address, automatically routed to Microsoft DNS server, right? So even if any internal user wants to access Google DNS server, he would not know and he would end up using Microsoft DNS server, because ASA firewall will reroute this query to Microsoft DNS server instead of Google DNS server. So this is the use case where twice NAT would be helpful. We will see in the next lecture video that how twice NAT make this possible.